First of all, we will have Asanka, who is CTO at WSO2. He will be talking about the API first internal dev platform, how it drives the digital experience as well. So, Asanka, I pass the time to you. Thank you.
Hello everyone, good morning, good afternoon, good evening. I'm Asanka Abeysinghe, CTO at WSO2. WSO2 is a technology company that we are providing API management, integration, identity and access management solutions to create digital experiences. But today I'm not going to talk about WSO2. So the topic that I picked today is about how you can leverage an internal developer platform which is built based on API first principles and deliver digital driven experiences. So I would like to thank the API Days Hong Kong organizing committee for inviting me this year as well to deliver this talk. So during 20 minutes, I will take you through a journey and explain this concept. So before jumping to the internal developer platform, I would like to look at this concept of abstractions. So I put this quote, abstractions are like your morning coffee because you see abstractions everywhere in your day-to-day life. So I'll take a few examples to explain this. The first example is maps. So we use maps a lot when we have to move from one location to another location, and maps simplify that process of uh, moving from location A to location B and how to navigate through that particular path. And it is simplifying the finding the path, and it reduced the complexity. We don't have to talk to strangers, we don't have to look for landmarks, and it is providing the shortest path as well as quickest path for us to do this particular process. So I'll take another example, transistor radios. So this is not a Gen Z thing, this is a Gen X thing, that when we grew up, we used to listen to music using transistor radios. So if you take a transistor radio, you will see three knobs. First knob to tune the channel, second knob to select a channel, and then the third knob to control the volume of the radio. So that is very simple and a very user-friendly interface. But if you turn the radio or flip the radio and then look at the back side, you will see a very complicated circuit board with transistors, capacitors, and resistors, a lot of equipments, and it built on top of a circuit board and providing this capability. So that's basically another good example for abstractions, that the interface of the radio hiding that complexity that you see in the behind of the radio. So those two are like the two physical examples about abstractions. But in the software world, we find many abstractions as well. I would say the entire principles of software engineering is built based on different type of abstractions. So there are two fundamental principles when it comes to the software abstractions: encapsulation and partitioning. Encapsulation is basically hiding the complexity inside the particular operation or like a particular module that we call, and it is exposing those capabilities in a simple way through the operations. So the modern operations are one we call APIs. So that's where the APIs coming and playing a picture. And hiding the complexity we call as the encapsulation. So similar to the transistor radio example that I took, it is hiding that complexity inside the module and then giving these capabilities through an API as operations. And software industry is very complicated when it comes to building systems, because we build large systems to facilitate many different type of business capabilities, as well as providing great digital experiences. So we have to divide that larger problem into many pieces. So that's where the partitioning coming into the picture. And as you can see this picture, that there's a number of modules, and same thing you can do, and how you module these things will come based on different type of designs. So when we look at the evolution of these abstractions, we can take a couple of milestones. The first example is Barbara Liskov, who invented abstract data types. Thanks to her, we are using stacks, queues inside our programs, and then using it without any issue. So that kind of simplify how you put a value to a stack, or how you retrieve a value from the stack. And without her introducing this abstraction layer, we would have wasted a lot of time coding those inside our programs. The second example is relational databases introduced by Edgar Cod. So Edgar introduced a way to store data, moving away from the traditional file system based storages and ISAM type of storages into a proper relational database. So in his introduction, we started storing data inside tables and columns, and Edgar introduced a language called structured query language to retrieve this data easily, as well as in a very unified way for us to retrieve these data. And that was a game change. And if you look at modern abstractions, Kubernetes is a really good example. Kubernetes has become the Linux for infrastructure, that we use it to deploy most of our workloads today. And Kubernetes is just like a traffic controller for me, not a traffic controller in the intersection, rather a traffic controller in a busy airport like ORD or San Francisco or JFK. So it is controlling the incoming traffic as well as outgoing traffic. So while Kubernetes is simplifying the deployments, it is handling the deployment related functionalities like scalability, high availability. And as DevOps engineers or developers, we should not worry about that. So those are three examples that we can take about software abstractions. And there are many architecture abstractions as well, like microservices, event driven, so and so forth. So I took one example from architecture style that I introduced in 2018 called cell-based architecture, a pragmatic architecture view, and a great abstraction for distributed or microservice based architecture styles, that you have a cell as a construct and you can organize components or services inside the cell and manage large systems. And if you are interested, you can read the paper. I have put a URL there. It's released under Creative Commons 4.0. So feel free to contribute, criticize, and make a comment. So if you build a system using cell-based architecture, it looks like this. You will see many cells and talking to each other and dividing that particular problem into small pieces, like fundamentals of abstractions that we discuss about encapsulation coming from cell boundary, as well as the partitioning coming from cells. And domain driven design is one way you can use to organize these cells. A domain can map to a cell, or a subdomain can map to a cell. As I mentioned earlier, encourage you to read the paper. So the abstractions are really important for businesses as well, because it is a game changer, because it creates a new mental model, as well as simplifying a lot of complex things inside the organization, and create an environment for people to build new ideas and deliver them quickly. So if we step back and look at, as a technologist, as a developer, architect, or a technical project manager, what we are really doing, we are creating digital experiences for our end users. So end user can be a customer, partner, or a internal employee. So every IT expenditure, as well as activities that we do, like a piece of code we write, architecture diagram that we draw, or project management plan we do, all these are connected to deliver this digital experiences for our end users. And it is very important building these digital experiences because we are living in a digital economy, or sorry, an experience economy. To explain the experience economy, the best example is a coffee cup that you buy from a coffee shop. If you assume it cost around $5, bulk of that will goes to the experience you get. The ingredients that they use to make the coffee or the service that they provide cost minimal, but experience you get inside the coffee shop, like the internet, seating, music, people you meet, all these things are part of that particular experience, and you go for that better experience, not only for the taste of the coffee. So that is a really good experience example for the experience economy, and this is the value or the a differentiator for any organization, because buyers go in for the best experience when they have two options. And I personally believe in experience economy is evolving and it will move to a value economy. I'm in the process of writing a blog post about value economy as well. Stay tuned, it will release soon. So I took this quote: the customers of the future are not asking for efficiency, they want experiences, happiness, and relationships. I I specifically strike through of the future because this is already happening, and the great digital experiences we are building are based on these experiences, happiness, and relationships. And keep the technology hat out and become a normal consumer, we also follow the same. So that's where, like, I see software industry is a very creative industry similar to the movie industry. So I call these software industries like movie industry. In movie industry, you take an idea, go through a production phase, and then release it. Similarly, in software industry, you take an idea, do development, and you release it. Only difference is in software the iterations are really short, you keep on releasing, but in movie industry the remake will come once in a while. But the thing that I want to highlight and emphasize, both are very creative industries, and to be creative you need a great platform there as well. So to be creative and operate in that manner, we need a foundation. That's where the concept of a business abstraction coming. We spoke about technical abstractions a lot, and we are moving to business abstractions because that's where we have to focus. So I keep abstractions at three levels. I call it as the triple layer of business abstractions. First, you get the deployment abstractions layer, then you get the business abstractions layer, and inside that, you see the domain abstractions layer. When it comes to the deployment abstractions, it's about CI/CD, DevOps, GitOps, SecOps, observability, multi-cloud, those type of capabilities we need to consider, and we had to build that particular layer to seamlessly deploy and manage the workloads that we have to run. So that's where the complexity is coming. I took this picture, I took these logos from Cloud Native Compute Foundation landscape. But if you go to Amazon, if you go to Google, you will see the same complexity, that you had to wire a lot of these capabilities and build a platform. And if you talk to a CIO or a CTO, what they are really doing is building this abstraction layer by spending a lot of people as well as a lot of time, and it is not easy. So when you have that the deployment abstraction layer, you can build a business abstraction. That is a fun part is. So you create services, you create functions, you create APIs, events, data, like that, the things that require to create a business functionality. And those business abstractions can be categorized into domains. That's where you do the partitioning. Either you use domain driven design or an architecture concept like cell based architecture, and group these workloads and have a proper way of managing that. One advantage of doing that is then you can use concepts like two pizza teams and have proper agility inside your organization. As a result, you expose your business capabilities as APIs, events, and data to the consumers. Then once you have that abstraction layer done properly using APIs, events, and data, you can start building applications. And it can be a mobile app, it can be a web app, or it can be a feed into a large language model and consume these business capabilities, and end users will come and consume it. So this is where the concept of internal developer platform is coming. How you create this foundation for people to come and build business abstractions is where the internal developer platform concept is coming and playing a role. But as a business, the deployment abstractions are not unique for you. Everybody is using Kubernetes, everybody is using service meshes, everybody is using Docker, everybody is using Kafka. So you will not get a competitive advantage from the deployment abstraction layer. Your advantages are coming from the business abstraction that you create that is unique for your organization. So you have to focus on that. So building a deployment abstraction layer will not give you any competitive advantage. The competitive advantage has to generate from the business abstractions as well as the experiences that you are building on top of that. And as I explained, that combination of that foundation, we call it as an internal developer platform. And the advice that I would like to give from my experience, don't build it, because it will take time and it's a never ending task with the technology enhancements happening as well as business changes happening day by day. So API is the glue for this entire concept. And if you take an internal developer platform should build on API first approach as well as entire communication within the components or the business abstractions that you build should happen using APIs, as well as the capabilities that you expose out of the internal developer platform should expose as APIs. And it is very important to have a proper API management in your internal developer platform, and it has to be API first. I would like to repeat that. And the idea here, basically think from API first design as well as pick a platform that is supporting API first as well. So once you do that, you can have a proper composable enterprise or a modular enterprise that you can wrap all your system of record layers into domain services and expose them as domain APIs. And then you can introduce experience APIs if required and start building these end user applications for your customers, your partners, and for your employees as well, and create a proper digital enterprise and service all your stakeholders with great digital experiences. So as a technology provider, we are contributing to this concept. So we have introduced a bunch of product offerings to do API management, SaaS offering, a Kubernetes native offering, as well as a traditional server-based offering that you can run it in anywhere. And if you are interested, you can go to this URL wso2.com and find more information. Having said that, I spoke about the internal developer platform. So WSO2, we introduced the internal developer platform as well that we call as Choreo, that you can run in any Kubernetes cluster and then get that end-to-end development experience and simplify the creation of your digital experiences. So it's creating a great abstraction level. And if you are interested, you can go to this URL and find more information about that. So in summary, my advice is don't build an internal developer platform. Focusing on building business abstractions and create the competitive advantages. Once you do that, it's a matter of just add developers, because you get a very effective, seamless environment for your developers to build these experiences for your end users. So if you like to get more information, these are my contact details. I write a lot in my blog called architect2architect.com, and I publish in various other publications as well, like Forbes. You can find all my publications from this much rank link, and I am active on LinkedIn. You can find me on LinkedIn and then connect, and we can have a conversation, as well as I am available on X platform, and my X handle is Asanka MA, and you can follow me and get more and more insight about this. With that, I would like to hand over to the moderator, and if you have any questions, please raise it, and I'm happy to answer them online or offline. Thank you very much.
The API Connect Hong Kong 2023 conference is powered by bNovelty Limited. Check out more API-related education content on bnovelty.com or apidays.hk for more information.